We, Team Algo Alice, and our project is titled as FAREGUARD Smart Bus Ticketing with Real-Time Fraud Detection and Passenger Insights. Usually, lakhs of people travel daily in Indian government bus, but the system faces major challenges. The biggest issue is ticket fraud, where passengers buy short-distance tickets but travel beyond their limit, leading to huge revenue losses. Unlike the metro, buses have no automated monitoring and conductors rely only on manual checks. And two, checking by external authorities at bus stop occur rarely, and even if it occurs, it is a time-consuming job and not an efficient method in fraud detection. To overcome these problems, we propose FareGuard, an app built with Flutter. With our digital ticketing app, passengers can book ticket based on source and destination with time-bound validity. Our fraud detection system compares passenger GPS with bus GPS and also compares the accelerometer and gyroscope value to prevent misuse. We also have feature of showing count detection in our app, which is beneficial for the passengers. On the whole, our system is inclusive and scalable while ensuring metro-like transparency at low cost. Now, let us see the demonstration video of our project. This is the sign-in page of our app. Here, the details of the user is being filled, and after filling with the details, an account is being created successfully. This account can further be used to access the app. Here is the home page of our app. Now, we move on to the settings page where different functionalities be accessed. Here, we can also change the theme of the app and use. Now we move on to Find Routes option. At first, location access must be given by the user. We can view the nearby bus stops in our app, which shows accurate bus stop details, and by clicking the bus stops, it shows the navigation for those too. The map is integrated with accurate location access, which is seen here and is also verified successfully. Now we move on to ticket booking feature in our app. We need to select the source and destination in our app, and if we are booking ticket in our home or different location, and warning is shown if the distance is more than 500 meter to reach the stop. And after that we are proceeding with the payment. For payment process we used Reatime integration, and after filling with the details the payment is successfully completed and ticket is generated. This ticket can be used for further processes. We move on to fraud detection algorithm demonstration. For now, we use a ticket inspector app which compares motion, location and speed of the host with the passenger who booked the ticket. While changing the motion pattern of the passenger phone, the access values are changed differently, which is compared with the host, and on keeping it static, the motion of both is being same and there is no warning being shown. Warning is shown only when there is some kind of anomalies detected. We can clearly see that the device is kept at different axis position and correspondingly the accelerometer and gyroscope value is changed and can be seen in the ticket inspector app. This is compared and warning of fraud detection is shown on mismatch. The accelerometer and gyroscope value of the host is continuously getting updated in the Firebase, which can be seen here. On changing the position, the values keeps on changing. Not only this, the accelerometer and gyroscope values of the passenger is also continuously getting updated and it can also be seen in Firebase. And visible changes are also seen based on the receiving data. Another major challenge for commuters is overcrowding. At peak hours, buses are packed beyond capacity, while another bus on the same route may be half empty. Without real-time knowledge, passengers are forced to board crowded bus or switch to expensive alternative. To address this, we implemented passenger count detection by integrating a Raspberry Pi with Sony IMX camera. The count is detected and the passenger count is displayed, and on exit the count gets decreased. We can also see that the count increases when passengers are added. All these data are updated in Firebase correspondingly. Based on the Firebase count feed, the count is shown in the app. The entry and exit count is calculated correctly, and we can also see that the count gets updated accordingly in the demonstration. These data are updated correspondingly in Firebase, which can be further seen in the app. This implementation is much more beneficial for other passengers who wish to travel through bus. We have other features in our app like available bus stops, contact support, active ticket and notification feature. While metro systems achieve transparency through expensive gates and infrastructure, our approach brings similar accountability to bus but at a fraction of cost using AI and cloud-based solution. FareGuard is more than just an app, It is a vision for future of public transport in India. With this system, we take one more step towards a truly digital India. Thank you.